For this problem, we have the tug and Berg score, and we want to find the correlation between them. Our tug score is our x, and our Berg score is our y, and so to find correlation, we need various sums from this data. We want to add up all our x values, so 2.2 plus 2.3 plus 3.0, and so on, and when you do that, you'll get 102.8. We want to add up our y values, 51 plus 52 plus 53, and so on, and for the sum of the y's, you'll get 729. You want to square your data values and add them up. So if you do that for the x's, you'd take 2.2 squared plus 2.3 squared plus 3 squared and add those. What you'll get for the sum of the x's squared is 767.4. You want to add up your y values squared. So 51 squared plus 52 squared plus 53 squared and so on. And for that one, you'll get 33535. And then the last sum we need involves both x and y at the same time. You multiply the values and then add them up. So you would take the 2.2x times the 51y, and then the 2.3 times 52, 3.0 times 53, multiply all the x's and y's, and then at the end add those all together. And what you should get for that quantity is 4520.1. The last thing that we need is our n, which is the number of data pairs. We're told we have 16 people. We could also count that from the table. So n is equal to 16. So our correlation, which measures the strength of our linear relationship, is calculated by taking your n times your sum of x's times y's. So 4520.1 minus the individual sums, so sum of x's times sum of y's. And if you've calculated slope, you'll notice that that quantity is actually the same as the numerator of the slope. And what that's going to mean is that the sign that we get for both, if they're positive or negative, it's going to match for both the correlation and for the slope. In the denominator, we have two square root terms, one with x's, one with y's. And what we do is take the sum of your values squared, so for x's, 767.4, have that being times 16. Sorry, I've got the 16 in here. And then we subtract the sum of our value then squared. So this will be 16 times 767.4 minus our sum of x's, which is 102.8, and we square that quantity. Same thing but with the y's, 16 times our 33535 minus our sum of our y's, 729 squared. So if you calculate this, what you should get back, you can double check this, is negative 0.885. Now we want to comment on what this would tell us about the linear relationship between tug and Berg score. Two things we want to look at. First, we want to look at if our value is positive or negative, and that'll tell us the direction of our relationship. We have a negative value, so a negative correlation means that you have a negative relationship between your variables. That will mean for us that if we increase our x, our tug score, we're going to expect a decrease in our Berg score. The other thing we want to look at is what's the number we got back. So we have a negative and then we have a 0.885. The value is going to tell you how strong the relationship is. With 0.885 being near 1, that's going to tell us that we do have a strong linear relationship. When you have something near 0, you have a weak relationship. So we have a negative and strong, and this is measuring always the strength of the linear relationship when you're looking at correlation. So tug and Berg score have a strong negative linear relationship.